Factoring when you have perfect squares. So this is just kind of an extra step or a shortcut. It doesn't always have to, you don't always have to use it, but you can when you have perfect squares. So if it's the sum, you're going to have it as a plus b squared or a minus b squared. And we'll talk about the difference in those two. And the difference, you're going to have a plus b and a minus b. You're going to have both of those parts. So what you're doing is you're looking for the square root of a, and you're looking for the square root of c. Now, you could do this the long way like we did for the last two lessons, but if you see that they're both perfect squares, then you should do that. So the square root of a, so the square root of r squared, is just r. Then this is the square root of 4, which is 2. So this is the difference, okay? So when it's the difference here, the minus, that means you're going to do this one. So you're doing r plus 2 and r minus 2. You could go back and check this also. If you were going to FOIL this back out and double distribute, you'd get r squared plus 2r minus 2r minus 4. And those would go away and you'd get back to your original solution. So that's a way that you can double check that you're doing that correctly. Same thing on the next one. The square root of x squared is x. The square root of 16 is 4. So this is a difference problem again. So you're doing x plus 4 and x minus 4. And again, if you want to find the actual answer for this, you would just set them both equal to 0. Okay, so looking at 3 and 4 here. So what I know is this has a perfect square root and this has a perfect square root. So the perfect square root of 25r squared is 5r. The square root of 16 is 4. And I need it to be negative 40 in the middle. So what I know is going to do that is to say minus 4 and minus 4. So then when I rewrite my answer to this, 5 minus 4 squared, because there's two of them. And again, you could double check that by going back and FOILing those together. But your insides, this would give you negative 20r, and this would give you negative 20r, which is the negative 40 that you were looking at. So you just need that negative sign there twice. Okay, perfect square roots, 2n and 3. This one is a difference. There's only two parts to it, which is another way that you can know that you're using your difference formula. So 2n minus 3 and 2n plus 3. So your next one, again, you have two parts to this, 1 and 2. So this is going to give you 5v, and the square root of this is 1. So I have 5v plus 1 and 5v minus 1. So think about if it's two parts, you're going to have two answers, two different answers. Greatest common factor, or the root of this is 3k. The root of this is 5. So 3k plus 5 and 3k minus 5. Okay, then looking at our last two. So this one has three parts to it. So we know that it's going to be one of the sums. But what you're looking at is the first and the last. So the root of 25b squared is going to be 5b. The root of 16 is 4. So I have 5b plus 4 and 5b plus 4. And how do I know it's plus? Because that's a plus sign. Because I need it to add up to a positive 40. So this would be 20b, and this would be 20b. I need it to be positive. So when I write my final answer, because there's two of them, when there's two of something, that always means it's squared. Okay, so looking at our last one, what I would do on this is I would rewrite this. I would write it in standard form, in order, like this. So I just flip-flop those around, kept the signs with it. Then what I would do is divide by negative 1. If you divide everything by a negative 1, you get v squared minus 1. So now we have a problem that we're used to seeing. The square root of a is v, the square root of 1 is 1, and you know that there's two parts to this, so this is v plus 1 and v minus 1.